How about we gotta make these programs and we gots to make them better somehow?
No. Everyone knows we need better programs. We need programs faster. We need programs that don't break. We
It's
need
becoming
programs.
increasingly important to the data processing industry to be able to produce more programming systems and produce them with fewer errors, at a faster rate, and in a way that modifications can be accomplished easily and quickly. Structured design considerations can help achieve this goal. And that, gentlemen, is that. Finished. Here we have it. Coupling. The single concept that will, in the years and decades to come, shape the structure of all source code everywhere. It'll become so ingrained that programmers will act on it without thinking, without the slightest reflection. Coupling will decide how components are shaped and how they fit together. Coupling will decide which software makes a profit and which does not.
Oh boy!
The coupling that we have written here today, gentlemen,
Will be the single concept that changes the world forever?
will be the single concept that changes the world forever. What the...
Oh, what was that?
I'm starving. I haven't had a thing since breakfast.
This place does a great lasagna.
Now that sounds like a good idea.
Ow. That's the second time today that's happened.
What?
My knee, it just creaked or cracked again.
You're an old man.
Might go see the doctor after work.
Oh, but you know who doesn't think you're an old man? My friend Annie.
The one with the hat fetish.
Yeah, she likes you. I told her you'd ask her out.
What? I don't want to date her.
Of course you do. She's smart, funny, loves life.
She wears weird hats.
That she does, but her good points outweigh the hat thing.
Speaking of weird, something happened in work today.
Your knee cracked?
No. I wrote some code, put it up for review, got comments back all good and insightful, except for one. One blahed on for a bit before ending in, which will lead to an anemic design model.
Anemic. Don't you hate those anemic design models?
Thing is, now I wonder, would it have led to an anemic design model?
Well, did it lack power, vigor, vitality, or colorfulness?
No, or I don't think so. What does that mean? How does code lack vitality or colourfulness? What does vital, colourful code look like?
Not like whatever you put up for review, apparently.
Good afternoon, folks, and how are we today?
Anemic.
Hungry.
Excellent. What can I get you?
Lasagna and lots of it.
I'll just have the chicken sandwich, thanks.
Lovely. Back in a tick.
Can I ask you a question? When you think of programmers, what do you think of? What sort of people do you think programmers are?
Oh, I don't know. Sort of nerdy.
By which you mean?
Well, educated, but maybe not social rock stars.
Educated, exactly. Not everyone can whip up an app to connect California to Sydney. You have to learn that, and it takes time.
I'd imagine so.
Now, as a waiter, you know exactly what good waiting looks like and what bad waiting looks like based on how satisfied people are with their service.
That I do, sir.
And bridges. You'd certainly hope that the people who build bridges would know a good bridge from a bad one.
That I would.
So you'd think that these educated programmers who spend their entire careers writing programs would know what good program source code structure looks like, wouldn't you?
Well,
How would you feel if I told you that with source code structure, it's really hard to tell good from bad? That programmers have no absolute rules to distinguish good from bad, and that it's all horribly fuzzy.
this would distress me indescribably, sir.
Wouldn't it?
Oh, far beyond my ability to express.
Structure. I'm hungry.
I think it's safe to say that should your supposition prove correct, civilization might crumble, life might end, and the universe as we know it might shrivel into a tiny piece of exotic matter and tunnel itself out of existence.
Thank you. Well, that wasn't weird.
Why does it bother you so much that you write anemic code?
Oh, I'm not the world's best coder. I sometimes write bad code. But what bothers me is that sometimes I write what I think is good code, and then someone can still call it anemic. It's just so subjective. Can there ever really be good code if just anyone can think it's bad? Is goodness just in the eye of the beholder? Where are the rules? Okay, let's take an example. I'm not an electrician, and you're probably not either. But look at this.
Do we have to do this now? My lasagna.
This'll just take a sec. Here are two pictures of electrical cabling, A and B. Are they more or less the same, or are they significantly different? Most people would say that they are significantly different. A looks tidier, B looks messier. With just two examples though, it's not so interesting. But if we examined loads of cabling and found that most looks like B, wouldn't we then wonder why A looks so different? This is the question we're interested in.
And this has to do with source code because...
Because, do you know what this is? That's right. This is a Java package. Okay, let's be clear from the outset. This channel is, initially at least, focused on Java source code.
Get over it.
In Java, the most coarse-grained encapsulation component, and hence the most appropriate for large-scale system analysis, is the package.
If, of course, you ignore modules.
Well, yes, modules, but we'll stick to packages for now, as most of us are more familiar with them. This, indeed, is not an actual package, but a representation, a model. Here's a second package, and we'll represent a dependency from one package to the other with a line. A straight line means that the upper package depends on the lower. In this case, X depends on Y. A curved line, such as this, indicates a dependency from the lower package to the upper, so now Y depends on X. What does a well-structured Java system look like? Hang on, I've downloaded a ton of Java systems to my phone.
He really has. He keeps this stuff on his phone for, I don't know, emergencies or something.
A well-structured program, we think, looks like this. These are the packages, and these are the dependencies. Now, this can seem complicated at first, and we don't have time right now to show why we think a well-structured system might look like this. For now, just note how easy it is to identify which package ultimately depends on which. This package, for instance, depends to some degree on all these. This depends on these. For most of the packages we might choose, we can easily see which packages they ultimately, transitively, depend on. And there aren't that many. This, we think, is a good thing. Now let's look at a system at random, not one specifically chosen because it's well structured. Ready? Here it is. And here are the dependencies. Remember those electrical cables? Well, is system B more or less the same as A, or is it significantly different?
I know. Lasagna.
Give me a sec.
And while we're here, is time passing back in reality, or am I just adding to my wait time here?
Well, you wrote this place, but yes, time's passing.
So did everyone in the cafe just see two people disappear? Won't that cause ructions?
No, we've been replaced by ultra-advanced simulacra AI. No one will know the difference.
Here we are, one chicken sandwich and one gigantic lasagna. Oh, and I was thinking, sir, and if I may be so bold, I disagree with your early postulate. Programmers can tell good programs from bad based on the principles that skewed source code size distributions tend to skewed costs, and that the probability of simultaneous parent-child change is greater than the probability of a parent change with any other component.
Let's do our little experiment again on this system. Take a package at random and find all the other packages it ultimately depends on. Take this one.
Ew.
That's a lot of packages. This one?
Ew again.
In this program, most of the packages you might choose depend on most of the other packages in the system. This is probably not good. But again, our brief look doesn't allow us to reach any conclusion. Maybe the system is better, but only a specialist can tell. And anyway, with just two examples, it doesn't matter so much. So let's take a look at some more open source Java systems at random. Here's another one. And another.
Oh dear.
And another. It goes on and on. These systems all seem similar to one another, yet very different from A. Why?
That one's nice.
Yeah, that one looks well ordered, but most don't. This is the question we're going to investigate over the next few episodes. Why are these systems so different? And do you want to know what's really surprising?
Only if what's really surprising needs a really short explanation.
The structure problem was essentially solved 40 years ago by three chaps, Larry Constantine, Glenn Myers and Wayne Stevens. They wrote a paper called Structured Design, one of the greatest computer science papers ever written. Though I think it was mostly Constantine's work, because he went on to write a book of the same name, but without the other two co-authors.
No.
Yeah, one of the authors really just collected his thoughts, apparently, and the other just stopped them all bickering.
Wow.
It's true. He says here in the book's preface, Myers, one co-author, paid me the tribute of turning lecture notes from my course into the paper. And, for yeoman's service in editing and warding off open warfare, Wayne, the other co-author, was awarded senior authorship. Anyway, the paper lays out for the first time probably the two most important concepts in source code structure, ripple effect and coupling. You just can't do source code structuring without understanding these two concepts. They are all important. You might even say that source code structuring is simply the application of both principles.
You know you're preaching to the choir here, right?
I do seem to be unnecessarily belabouring the point, don't I? But the thing is, these three gents largely solved these structural problems, and System A here was designed according to their principles. But if these other systems look so different, have they not been designed with these principles in mind? Because most programmers love to talk about loose coupling. So where is it? Have most programmers misinterpreted it? Or is it System A that's poorly designed? We need to investigate this. I'd love to ask Constantine and his buddies whether these B structures respect ripple effect and coupling.
Oh, you'd like to meet them?
To ask them about a paper they wrote 40 years ago. I'm not even sure they're still alive.
No, I mean, would you like to meet back then, when the paper was fresh in their minds?
Why, do you have a time machine?
No, of course not. But I do have a time portal. But first, oh my god, I need food.
A time portal. Well, that's convenient. So, you just happen to have a time portal that can take us back to the 70s.
Oh, this is good.
A real time portal. With super cool graphics? What is it, a rip in the air? Or a wavy water surface like in Stargate? A DeLorean?
Yes, I have a time portal. And yes, we can go back to your three amigos, but on one condition. You ask Annie out for a date.
Ugh. Okay, one date.
I'll come by your apartment tonight. We'll go then. Now, eating.
I think I'm getting the better part of this deal, he said as he chowed down on his piping hot bowl of chicken sandwich.
Structure!
Hey, Doc!
Come in. How are you? What can I do for you?
Well, it's my knee. It's starting to creak.
Ouch! Getting old, Structure.
Yeah.
Sit down here. If it's cracking, we can record it.
Seriously? You record knees?
Knees, hips, elbows, any joint really. You can get a lot of information from a recording. How the sound travels through the bone and surrounding tissues tells an expert almost as much as an X-ray, but without all that nasty radiation. We even have special mics for different joints.
Knee mic. Why do they shorten microphone to mic? Everyone knows it's a mic.
What can I tell you, Structure? I'm but a humble doctor.
Wait a minute. Anemic? Why, it's the greatest programmer in the galaxy.
You decent?
Yep.
How's creaky knees?
Well, I'm excited.
Because of your date with Annie?
Oh, I'd pleasantly forgotten about that. Way to kill a mood. No, I'm excited because I'm going to see my first time portal. Did you bring it?
Course I brought it. I have my phone, don't I?
Oh, it's an app.
Course, it's an app. What isn't an app these days? You want to go now?
I want to go now.
Whatever you say, Captain.
That is the saddest looking time portal I've ever seen.
Yeah, strange. I got 4.5 stars on Google Play.
It looks like an old ZX81 game. So, do we just walk into it?
Think so.
You've never used it before?
Never really saw the need.
Well, after you.
Oh, after you, good sir.
The coupling that we have written here today, gentlemen,
Will be the single concept that changes the world forever?
will be the single concept that changes the world forever. What the?
Oh, Constantine, Mars, and Stevens! It's okay, we're programmers!
Ah, good.
We just used a time portal to come visit you from the future, from the year 2019. And we can prove it. That paper you're writing there, I have a copy of the finished published article right here. It's become an invaluable part of our computing history.
I expected as much.
Tell me, future boy, who's president of the United States in 2019?
Donald Trump.
Donald Trump, the real estate guy. Ha! And who's the vice president? Jerry Lewis?
What? Look, that paper was a turning point in our technological era.
This is good.
You can have a look if you like.
Thank you, but no thank you. We have just finished writing it.
Fair enough. Did you know back then, do you know now, how important these ideas will be?
We have
Of course we know.
our hopes, but it's clear that our ideas found fertile minds in which to flourish.
They certainly reached a wide audience when you expanded on them in your later structured design book.
We're gonna write a book?
But tell me, do you have any program structures from the future that I could look at to see how our work has influenced the world?
Funny, that's precisely why we came. I have them here on my phone.
Your phone?
It's a long story. Here, let me project them on this wall.
Enough. Leave us. We understand now. Go back through your fantastically futuristic temporal anomaly.
What, are they no good?
Leave us.
But your two concepts are crucial. We...
Two concepts?
Yeah, coupling and ripple effect.
Ripple effect. What the blazes is a ripple effect? Before you go, perhaps you should leave us with your version of our paper. It might help us spot some spelling mistakes, formatting errors. You understand.
Sure.
Now, leave us.
Oh, right. Well, that didn't go to plan, but it was still great to stand there in the presence of true geek royalty.
Yeah, and you know what's even greater?
What?
That you have a nice date with Annie to look forward to.
Oh, another mood killing. It's like you take contracts out on them.
I like to think I'm more of a sophisticated mood killer. I'm the James Bond of mood killing. There's no mood I can't extinguish.
What was that?
I'm not good at the Sean Connery accent.
You know his name is S-E-A-N, Sean Connery? Putting on the Bond voice and calling him Sean, that's a little insulting.
Well, you can explain all that on your date.
Annie? Hi, Annie, it's Structure.
Oh, hi, Structure. Good to see you.
You too. Nice hat.
Thank you.
So, want to catch a movie?
Sure, but first I gotta ask, is that your real name, Structure Science?
Yeah, my parents had a sense of humor. And destiny, I like to think. What's your family name?
Mac. No relation to Freddie Mac, just Annie Mac.
How lovely. Let's go see what's... Wait a minute. Annie Mac?